This is going to be a video about how we add and subtract rational expressions. So again, because rational expressions are simply fractions with variables, I'm going to review how to add and subtract regular fractions first and then see how we can translate that. So let's do a recall here. We're going to do 3/4 plus 7/10. And let's remember how we add fractions. So the very first step is to find the lowest common denominator. We need to have the same denominator in order to add fractions. So between 4 and 10, the lowest common denominator would be what? Well, we have a 4, we have a 10. One way to do it is just to look at multiples of 10. So it seems like 20 works. So the LCD is going to be 20. So what I do is I give each fraction what it's missing here. So for example, the 4 is missing a 5. So I have to multiply it by 5, but I do the same thing to the top. And the 10 is missing a 2. So I multiply both by 2. You always have to multiply the same thing on the numerator and denominator. We end up with 15/20 plus 14/20, which gives us, remember we add the numerators but not the denominators, so 29/20. Okay, 29/20. Okay, so these are the steps. At this point we would reduce if we could, but we can't reduce. So this is our final answer. Now let's think about those steps there, because we're going to do the exact same steps with our rational equation. So what was step 1? Well, for polynomials, this is going to be to factor the denominators. The only purpose of this is so that we can figure out what the lowest common denominator is. So factor the denominators. Step 2, we're going to find the LCD. Now at this point I need to backtrack a bit. How do we actually find the LCD? So here's one way to do it. So I'm going to put this in parentheses. The product of the greatest power of each factor that appears in any denominator is the LCD. Let's read that again. The product of the greatest power of each factor that appears in any denominator is the LCD. Step 3. Let's remember what we did here. Notice in this last problem we multiplied each one by what it was missing, and then we gave the top that too. So we're going to do the exact same thing here. So I'm going to say rewrite each fraction using multiplication so that it contains the LCD as its denominator. Okay. Step 4. Add or subtract. At this point, they're going to have the same denominator since you've already changed them. So let's remember the rule for how we add fractions. Remember, we kept the same denominator and only add the numerators. Similarly with fractions. Although be careful, I'm going to write something a little strange here. Notice I have parentheses here. This is just to remind us that we put the whole numerator inside the parentheses, and that's what we're subtracting. We're not just putting a minus sign there. Okay, so the last step, simplify if possible. Notice in our example up here, 29 over 20 was already simplified. So there's nothing more we could do with that. But sometimes you're going to be able to simplify further. Okay, so let's try some examples. So number 1, we have u minus 17 over 18 plus u plus 1 over 9. So we're going to start by writing down the LCD. Since these are just numbers, we can't really factor this further. The LCD here is going to be 18. So we give each one what it's missing. Now the first one's not missing anything, but the second one is missing a 2. So I have to do the same thing to the top. I end up with u minus 17 over 18 plus 2u plus 2 over 18, which gives us 3u minus 15 over 18. All I did was I combined the like terms on the top. Now from here, can we reduce further? We're at the last step here. Well, let's try to factor. I can take a 3 out, I get u minus 5. On the bottom I get an 18. And sure, now I can reduce the 3 with the 18. That leaves us with a 6. So the answer is u minus 5 over 6. And that is as simplified as we can get it. Alright, let's try another one. We're going to do 5 over 4p minus 1 over 6p squared. So let's look at the numbers first. We have a 4 and a 6, so we know the LCD is going to have a 12. And then we look at p and p squared. But remember up there it says the greatest power of each factor, so we need the p squared. So what is each one missing? Well, 4p is missing a 3p, so I'm going to give the same thing to the top. And 6p squared is missing a 2, so I'm going to give the same thing to the top there. I end up with 15p over 12p squared minus 2 over 12p squared, which gives me 15p minus 2 all over 12p squared. Now I cannot cancel here because there's nothing that can be factored out of the top. It's prime. So I'm done. Okay, let's get a little more challenging. 9r minus 35 over r squared minus 49 plus r over r plus 7. Okay, so let's read our steps over. Step 1 was to factor the denominators, and notice this is our first problem where the denominators can be factored. So, the first one is a difference of squares. So I have r plus 7 times r minus 7. And the second one is just itself. So what's the LCD going to be? Well, for the r minus 7s, there's one on the left and none on the right. So I need to have one of them. And then for the r plus 7s, I have one on the left, one on the right. So the most is 1. I don't need any more than that. So I'm going to give each one what it's missing. At this point, the first one already is the LCD. So I need to add on the second one an r minus 7. I'm going to do the same thing to the top here. So I end up with 9r minus 35 plus, I'm going to distribute this r here. I get r squared minus 7r all over r plus 7, r minus 7. Let's go ahead and simplify the top and put it in descending order. I have r squared, and I have plus 9r minus 7r, that's plus 2r minus 35, all over r plus 7, r minus 7. Can I simplify? Well, can this factor? And it turns out, yes, we can factor the numerator, can't we? This becomes r plus 7 times r minus 5. Because 7 times negative 5 is negative 35, and 7 plus negative 5 is positive 2. And lo and behold, we can cancel the r plus 7s. We're left with r minus 5 over r minus 7. and there is nothing more we can do to reduce this. Alright, let's get to a really hard one. 5k over k squared plus 11k plus 30 minus 2k plus 1 over k squared plus 2k minus 15. So first step is to factor these denominators. So the first one becomes, well, what are two numbers that multiply to 30 and add to 11? That's 5 and 6. So I'm going to rewrite it as k plus 6 times k plus 5. Now the second one, it's going to be 5 and negative 3, right? K plus 5 times k minus 3. So we need to figure out the LCD. Now the first one has a k plus 5, so does the second one, so I put that. And then we have a k plus 6 there, and there's none on the right, and then the right has a k minus 3, and there's none on the left. So the LCD is just one of each. I'm going to give each one what it's missing. So for the first one, it's missing a k minus 3. The second one is missing a k plus 6. Now what? Well, it's getting annoying to rewrite that LCD every time, right? So I'm just going to save time and write LCD on the next step. 5k times k is 5k squared. 5k times negative 3 is negative 15k. Minus, and then we have 2k times k is 2k squared, and then positive 12k, and then positive 1k, and then positive 6. Now put it all together, we get 5k squared minus 15k minus the whole thing. Don't forget your parentheses here. This is why I said put parentheses when you're subtracting, just to remember to distribute them. We end up with 5k squared minus 15k. If we apply the negative sign, we get minus 2k squared minus 12k minus k minus 6. I guess I should have combined like terms up there, but I can do it here anyway, all over the LCD. Which gives us, well, let's combine our like terms. 5k squared minus 2k squared is 3k squared. Negative 15k minus 12k minus k, that'd be negative 27 minus 1 is negative 28k, and then minus 6, all over the LCD. Now, can we factor this top? Well, if we remember our grouping method, if we multiply 3 times negative 6, we get negative 18, and the middle number is negative 28. There are no two numbers that multiply to negative 18 and give us negative 28. So this is actually as fully canceled as we can get. So I'm going to rewrite it like this. And we're done. Tricky problem. There are a lot of steps involved. Hopefully that made sense. Now there's a couple more examples that I want to do to illustrate that negative sign trick. Okay, let's not forget that a minus b is the same as negative of b minus a. So sometimes this trick is useful for making denominators look alike without having to get crazy LCDs. So I'd like to show you an example of this in action. Sorry, this is number 5. I apologize. We have b over b minus 5 minus 4 over 5 minus b. Now before we find the LCD, what I'm going to do is I'm going to rewrite this 5 minus b. This is actually negative b minus 5, isn't it? Now I did that because I want to have b minus 5 on both. Now this negative sign, I can just move it to the top instead. Now I mean instead, so if I'm going to put it up there, the bottom becomes a positive. So I get b over b minus 5, and then I have minus a negative 4 over b minus 5. So they're actually the same denominator already, aren't they? I end up with b plus 4 over b minus 5. And nothing cancels because there's no factoring you can do. Right, so the important thing about this trick is to realize that subtraction can be reversed just by factoring out a negative sign. And we do this quite often. Let me do one more problem. 6 over 1 minus x plus 2 over x squared minus 1. Now we're not going to flip the left thing yet or anything like that. We just want to factor and see what we get. So the right can factor. This becomes, because it's a difference of squares, x plus 1 times x minus 1. Now notice, if I can turn that first guy into an x minus 1, this would be a lot easier of a problem. So I'm going to do that. I'm going to pull it out with a negative, like that. Then what I do is I move the negative to the top. Now we can see that the LCD then is just going to be an x plus 1 and an x minus 1. So I'm going to start by giving each one what it needs. The bottom one, because it has an x minus 1, is missing an x plus 1. So I have to give that to the top as well. And the second one already has what it needs. So I end up with negative 6x minus 6 plus 2 over x minus 1, x plus 1, which gives me negative 6x minus 4 over x minus 1, x plus 1. Can we reduce? Well, we can try factoring the top. If I pull out a negative 2, I end up with 3x plus 2. The bottom is still x minus 1, x plus 1. So even though I was able to factor something, it doesn't reduce. So this is my final answer, or I can even box this, because it doesn't matter. The factoring or non-factoring, it doesn't matter because it did not reduce at all. Okay, this section does require a lot of practice, so please do a lot of problems to practice for this. And I hope that this has been helpful. Thank you very much for watching.